Okay, guys, this is discrete optimization, and this lecture is actually as important as the material itself. It's basically about how you should look at these assignments and what are the various ways of approaching them, right? So, in a sense, what you're going to do is, what's going to happen to you is you're going to get problems that are basically thrown to you in your face, right? And you're going to get the boom, and you're going to say, what is happening to me, right? And you're going to say, how do I do this? And the more you look at these problems initially, you're going to say, wow, this is completely insane, okay? And so I want to tell you basically in this lecture how you can actually approach this thing in a reasonable fashion. And then I want to discuss the various ways these approaches can be applied to get a good grade, a passing grade, a certificate, or a certificate of distinction, giving you some advice on how you can do this. Okay? So the assignments have been designed to emulate, the real world. Okay, so you have to you think about it. Your boss is going to tell you, okay, so we need to solve the problem, and you have to figure out how to do it. He's not going to tell you how to do it. He's just going to tell you, this is what I want as a solution. This is what the problems that I want to solve. Get your act together, solve it. Okay, so it's like Kennedy, in the 60s when he told, he told America, okay, so we want to send a man on the moon, okay, by the end of the decade, right? So he said that, but he didn't say, okay, we have to build a rocket, we have to find, to solve these kinds of scientific problems, we have to find people who are capable of actually flying this rocket and things like this. No, he didn't care, right? The only thing that he wanted is solve me this problem. So I don't care if your rocket looks blue, red, is wide or thin or whatever, right? And so this is what this class is about. Okay, we're going to throw problems at your face, and we won't tell you how to solve them. We'll give you the means to actually solve them. We'll give you, the equivalent of the physics or the, engineering that you need to build a rocket for discrete optimization. But we won't tell you which pieces you have to assemble for it to work. Okay? So we basically give you the problems, and you have to find a way to solve them. Okay? Now, how you solve the problem? Okay, so we have these hats, right? So you use the first one. You see if it works. Doesn't work? Use another one, right? So, but we won't tell you which one has to be used, right? For one particular assignment, this one is actually tricky, right? So for one particular assignment, it's not very clear which hat is going to work, okay? So you may have to try several of them before you actually find a solution. Okay? And what the goal of the class is about, actually finding which of these hats is actually good for which of these problems. What is the real, asset of these hats? For what classes of problems are they good, and so on. Okay? So this is really heavy, so let me, bring that down. Okay? So to get started, you have to imagine yourself in a company, and your job, this is the other way this is the other important part. You have to imagine that your job, your boss is coming and saying, you have to solve these problems. Okay, get to work. Okay? So what we recommend is that the first thing you do is you implement something really simple, kind of a greedy solution. Get an understanding of the problem. Know that you actually solve the problem. Okay? You understand it. You have, you know all the facets of these problems. You know that you have a feasible solution. You know that you can solve this problem. Then you go to your boss and you say, look, I have a solution, and look, this solution is improving the practice in this company by 20%. This is great. You come to your boss and you get him excited, and your boss says, wow, this guy went fast. Of course, your boss is probably not stupid. He's going to say, if he did that in a week or in 2 days, he probably can do better. So he's going to look at you and say, yeah, but can you do better than that? Okay? And that's the second step. And the second step is about looking at your greedy algorithm, or whatever solutions you came up first, and trying to analyze it and trying to see if you can do better. And typically, you are going to move to more sophisticated solution when you do that. CP, MAP, dynamic programming, local search, whatever. Okay? And so in this particular case, you will try to improve, what you had before, but you have a baseline that you can compare to at this point and see your best you can. And so you can go back to your boss and say, wow, boss, I have a 30% improvement now. And so your boss is going to say, wow, this is great. And then, of course, he's not completely stupid. He say, this guy improved it by 20%, and no, by 30 more percent. So when are we going to stop? What do I know? Okay? And this is the point where it's probably, very important for you to relax. Okay? And try to find, some quality guarantees that you can give to your solution. Okay? So you want not only to find good solution, but also find a kind of a way to say, how good can I be? Okay? And so these are essentially the three phases that that you can go through. Start, easy, okay? Solve the problem. See how best you can solve the problem. Then improve. And then afterwards, find optimal solution or find, something that can tell you how good you are, okay? So start simple, build on it, and, make sure that you can progress, into more sophisticated solution, okay? But start easy such that you know what you're doing. Okay? So in a sense, what we are recommending, it always start with something easy, and then you have two approaches, either a quality-based approach or a scalability approach. And I'll come back to this, but some of the problems that you will encounter are very difficult to solve for very large sizes. So you will have to look at very scalable solution to get good solution to some of these larger instances. On the other hand, some of these techniques may not give you the best quality solution, so you may look at constraint programming or mixed integer programming to actually get better solution. And of course, what we also want is that you actually use both approaches and potentially combine them to get very high quality solution on all of the instances, okay? So in a sense, once again, this is about starting slow and then building using the blocks the hats that we are giving you and trying to get to, really high quality solution everywhere, okay? So the grading, once again, the grading is going to be based on the recognition that there is no silver bullet in optimization. Even for us, when we are given a new problem, it's not always obviously clear, what is the best solution and what's going to scale and how we model the problems and, what we can expect, okay? So, and in a sense, the assignments that you're going to see here are intentionally insane, okay? So they are going to make sure that one particular assignment, one technique is not going to work for all part of the assignments unless you're really, really, really clever, okay? But most of the time, some of the techniques will work on some of the instances, other techniques will work on other ones, okay? It's done on purpose, so that you get a sense of not only exponential growth, but also the fact that, wow, the structure of the problem is really important, okay? And so this is the insane part, but we are also very flexible, okay? So we give you ways to succeed and different ways to succeed, okay? And you can, for instance, take a scalability or, a quality approach, and they will be both fine in this class. You can say, okay, so I'm only focusing on scalability and trying to get solutions to everything. Or I'm going to try to get the best solution to some of the instances and kind of solutions, maybe not high quality solution on the other ones. So that these two ways are going to be ways to actually be successful in this particular class. Let me give you a little bit of a sense of this, of these two ways of actually approaching the problem, okay? So when you look at the particular problem, and let's say, so typically we have 6 parts in every one of these problems. Let's say that 4 are reasonably small, 2 are really large, okay? So if you do if you do an approach which is based on finding high quality solution, you may get the top grade, like say 10, okay, on 4 of them, and then a low grade on 2 of them, and that's going to give you an average, a value of 46 on that particular assignment. And that's a number for which you can get a certificate of completion. You can also do the opposite thing, which is, okay, so I'm going to focus on scalability, get good solutions, okay, like, 7 on all of these problems. And you get 6 times 7, which is 42, which is also enough to get you a certificate. Okay, so these are the 2 ways to do this, okay, and this is the 2 ways you can actually get a certificate in the class. If you want a certificate of distinction, you probably need to combine these 2. Now, one of the real things that I want you to focus on is that first get good grades, okay, so don't focus on getting 10s everywhere. You have plenty of opportunities, and I'm going to talk about how to approach the class from a time optimization standpoint in a moment. But try first to get good grades everywhere, and then beef them up. You'll see you will have a lot of opportunities to do that. Okay? So, and this is the key point. Okay? So if you take the first assignment, don't get obsessed. Okay? It's very easy to get obsessed in optimization. You see this thing, and you want to get a 10. You see another guy getting a 10, and you say, oh, I have to get a 10. You get, completely frustrated. Don't. Okay? Maybe the person knows more than you do. Okay? At this point. Okay? But this class will give you everything you need to get a 10. Okay? It's just going to come over time. So you can go do this assignment, get 7s, and be pretty happy. Okay? And then at the end you say, ooh, but these techniques I could apply to this first problem that I actually solved. And now I know exactly how to solve. You get back to it, and in like 2 minutes, I mean, I'm exaggerating, right? So you get a 10. Okay? So this is what this class is all about. You're going to learn things, and then you can go back in the past, fix your solution, and get much better grades. Okay? So don't get stuck on a particular problem. Don't get completely obsessive, okay? So in the past, some people have become so obsessive that, it was like we had to, cool them down, okay? So we don't want that to happen. Get good grades, come back to the assignment, and get better grades later on, okay? So you will have a lot of times also at the end, I mean not a lot of time, a reasonable amount of time to go back and fix the solution at the end. There is a buffer at the end just for you to do that. And a lot of people are basically exploiting this. Okay, so let me then talk about one last topic, which is how you should approach this class, such that is, you keep a reasonable level of happiness during, the time you take this class. You still get a social life. You still are in a good mood. You don't lose all your friends, your spouse, and all these things. Okay, and so let me give you an analogy. Okay, so the analogy is, last year, in 2013. When actually Rafael Nadal won Roland Garros, he was interviewed by somebody in the tournament, and they were asking me, how does it feel to win the tournament? And Nadal, this great tennis champion, said, well, I'm going to be happy for 2 weeks. It's great. And so you see this guy training like a beast for 50 weeks, and then he's happy 2 weeks of the year. This is terrible, right? I don't want that to happen to you. Okay, so look at this graph. This is your level of happiness. It's also your level of confidence, technical confidence in general. And so what you will see here is time, and this is the time during the class, okay, or during an assignment. And you obviously start with, a lot of confidence, a lot of happiness. You come there, you design this amazingly beautiful solution, and you start coding it. And then as you code it, and you fix things, your level of happiness is decreasing, your level of confidence is decreasing. You kind of get desperate. It's a pain to actually work on this and this. And then at the very end, wow, you get a big high because these things turn out to work. Okay? No, so this is essentially what Rafael Nadal is experiencing. He's training like a beast, and then he has these 2 weeks where he's happy. For you, it's going to be basically, let's say, a week of work, and then 2 minutes where you will be happy. We don't want that, okay? Because you will have to, go do the next assignments at that point. We don't want. That's not what we want you to do, okay? So what we want you to do is something like this, okay? So you start, at a reasonable level of happiness and confidence, and then you start building something which is easy. Let's say a greedy algorithm. Your confidence decreases, but not very much, because this is pretty simple. And then you get a solution, and you get a first high. And you say, wow, okay, so, I'm happy, I have something that works, and you say, good, okay? Then you start looking around, you see, oh, but, maybe there are people with better solution. Maybe I can improve this. And you start coding, let's say, a local search solution. And so it takes a little bit of confidence away from your level of happiness. You have to work a little bit harder. You don't see your friend as much. But then you have another high, wow, you have a really good quality solution at this point. And you say, oh, wow, this is good. Now you have a lot of confidence. Your confidence is increasing. And you say, oh, but no, I want some kind of guarantees on how good I am. Okay? And you say, oh, let me try a MIP approach to actually get that guarantee. That's a little bit tougher. Your confidence and your level of happiness is going to decrease, but it's a very short amount of time here, and then wow, a big high. No, I know how good I am, right? And you say, this is good, another high, and even higher. But you say, well, but this MIP solution for this scheduling problem is like a dog. Let me try CP to actually do better in terms of efficiency, and then you get the final high where you get this beautiful CP solution at the end. Okay, so this is what this class is about. This class is about being high all the time, legally high, right? All the time, right? So this is what we want. The dips are very low, the peaks are high, and that's the best way to actually approach this class. Don't wait until the last moment to experience this kind of satisfaction at the end. Okay? So do this like that. Okay, so have fun. It's insane, but it's a lot of fun, especially if you do it the right way. Okay? Don't get frustrated. You can always come back. You have a lot of opportunities in this class. Okay, enjoy it. Thank you very much, guys.